It was the kind of moment that makes the entire automotive world freeze. Not a whisper, not a click, not a single rumble from a turbocharged V12 could be heard over the roaring disbelief that echoed from garages to engineering labs across the globe. Koenigsegg, a name already carved into the granite pillars of automotive innovation, had just unveiled something that didn't belong in this world, or at least it didn't look like it did. For months, whispers of a new engine technology had trickled out of Sweden, shrouded in secrecy and loaded with speculation. People thought it might be an advanced iteration of the free valve system, or maybe a hybrid twin to the Lightspeed transmission. But nobody, not even the closest competitors or the most imaginative insiders, expected this. Because this time, Koenigsegg didn't just disrupt the industry. They redefined the very limits of what combustion was ever supposed to be. The dark matter engine wasn't just real. It was alive, it was terrifying, and it was a declaration of war against everything we thought we knew about propulsion. In a world stampeding toward electrification, where governments, automakers, and eco-warriors alike chant the end of internal combustion, Koenigsegg has flipped the narrative on its head. While most companies are busy building heavier batteries and denser grids, Koenigsegg has quietly engineered something that challenges the very need for that infrastructure. Imagine for a moment an engine small enough to fit inside a carry-on suitcase, yet powerful enough to launch a hypercar from 0 to 60 in under 2 seconds. Not theoretical, not on a test bench, but in production, real. This is what they've done. The dark matter engine weighs only 86 pounds, less than a sack of potatoes, but delivers 800 horsepower and over 900 lb-ft of torque. And it does all this while maintaining the guttural symphony of internal combustion and achieving a level of efficiency that turns hybrid engineers green with envy. But to truly understand the significance of what Koenigsegg has done, we have to peel back the layers. Because this isn't just another small, high-output engine. It's not just a clever turbo or an innovative piston design. This is an entirely new way to think about combustion. At its core, the dark matter engine is a single-cylinder-based, multi-chamber combustion engine with a design so radical it doesn't even follow the traditional layout of internal combustion norms. It breaks every rule, and yet somehow it works better than anything that came before it. Its architecture allows for modular scaling, which means you can take this design and adapt it to drones, motorcycles, boats, or even aerospace platforms without starting from scratch. The way it breathes, ignites, cools, and operates has more in common with futuristic spacecraft propulsion than with your grandfather's V8. It's as if Koenigsegg found a way to trap thunder in a teacup. Think about it. In an era where combustion engines are considered dinosaurs, how does something like this even exist? The answer lies in Koenigsegg's DNA. This is a company that has never cared about doing things the easy way. From the moment Christian von Koenigsegg founded the brand, the mission wasn't just to build fast cars, it was to build the impossible. They've pioneered free valve technology, which replaces the conventional camshaft with pneumatic, hydraulic, and electronic actuators, giving the engine unprecedented control over valve timing. They created the Lightspeed transmission, a gearbox that shifts faster than your brain can process. And they developed a triplex suspension system that defies physics by simultaneously reducing squat and enhancing grip. All of these achievements were mere stepping stones to this moment. With the dark matter engine, Koenigsegg has essentially rewritten the combustion rulebook. The engine operates at an astonishing compression ratio, rumored to be 18 to 1, allowing it to extract the maximum amount of energy from every drop of fuel. But that's just the beginning. The ignition system doesn't use spark plugs. Instead, it employs solid-state plasma ignition. Let that sink in. Plasma, not a spark, not a coil. Plasma ignition enables near-instantaneous combustion, dramatically increasing efficiency and reducing emissions. And the cooling system. Gone are the massive radiators and complicated coolant loops. Instead, Koenigsegg utilizes microheat exchangers and potentially even phase change materials, technologies normally reserved for satellites and space stations, to keep the engine operating at optimal temperature. It doesn't need a bulky flywheel either, which means it revs faster and feels more like an electric motor than a traditional combustion engine. That's the real magic here. It's not just that the engine is small and powerful, it's how it behaves. When Koenigsegg unveiled this beast to the world, tucked neatly inside the Gamera platform, people initially thought it was an electric motor. That's how quiet, compact, and responsive it appeared. But no, this is pure combustion. This is fire controlled by algorithms. This is the ancient power of fuel and oxygen, reborn through 21st century materials and control systems. And speaking of materials, the engineering behind the dark matter engine is a masterclass in material science. The block and head are made of ceramic composite alloy, a blend so light and heat-resistant that you'd expect to find it in jet turbine blades. The crankshaft is hollow and forged from carbon-titanium hybrid composites, minimizing mass while withstanding the stress of high RPM operation. Titanium internals, carbon casings, and aerospace-grade ceramics complete the package. It's not just about reducing weight. It's about reducing failure points, maximizing efficiency, and squeezing every ounce of performance from the smallest possible footprint. In terms of integration, the dark matter engine doesn't need a traditional alternator, starter motor, or even a conventional oil pump. These components have been reimagined and miniaturized, either integrated directly into the housing or eliminated entirely thanks to dry sump lubrication and micropulse oil delivery. Every component serves multiple purposes. Every gram has a job. The entire system is lean, smart, and brutally effective. It is the closest a combustion engine has ever come to behaving like an electric motor, and in many ways it surpasses them. This is why the world is watching. Because if this technology scales the way Koenigsegg promises, we are no longer talking about a niche hypercar innovation. We are talking about the potential to reshape entire industries. From aviation to marine transport, from off-grid power to emergency generators, the implications are staggering. It's not just the horsepower. It's the power-to-weight ratio, the modularity, the fuel flexibility, and the potential for integration into platforms that were previously deemed impractical for combustion. And that's where this story begins to shift from impressive to truly transformative. The moment Koenigsegg unveiled the inner workings of the dark matter engine, engineers worldwide found themselves staring at a machine that shouldn't logically exist. Not in this timeline, not with current thermodynamic limitations. And yet, there it was, sitting in the engine bay of the upcoming Gamera, a family hypercar that now seems like a Trojan horse for something far more revolutionary than performance numbers. Christian von Koenigsegg didn't just want to build a faster car. He wanted to fundamentally change our relationship with power, how we generate it, how we use it, and how we store it. The dark matter engine wasn't just created to compete with electric drivetrains. It was designed to coexist with them, to outperform them, and to prove that combustion is far from obsolete. Let's talk numbers. Not just peak horsepower, but true systemic efficiency. In early testing, the dark matter engine reached a thermal efficiency of over 50%. To put that in perspective, most conventional gasoline engines hover between 25% and 30%. Even the most optimized hybrid engines barely reach 40% under perfect conditions. But the dark matter engine, without relying on exotic fuels or massive battery packs, is breaking through a threshold previously thought unattainable without complete electrification. And that's the trick. It's not chasing EVs. It's outperforming them using different physics. How? It starts with a concept Koenigsegg refers to internally as energy phase synchronization. Essentially, the engine is not simply combusting fuel in a mechanical cycle. It's orchestrating a chain reaction, timed down to the nanosecond, to produce a shock wave of rotational torque that mimics the torque curve of an electric motor. This is achieved through ultra-precise fuel injection, variable combustion chamber geometry, and that plasma ignition system that bypasses the delays of traditional sparking. Instead of relying on multiple revolutions and inertia buildup, the engine generates instantaneous torque from a cold start, allowing for full acceleration from standstill with almost no throttle delay. That's why the Gamera, a four-seater car with luggage space, is expected to outrun almost anything else on the planet when this engine is engaged. But torque and acceleration are just a fraction of the story. What truly sends shockwaves through the industry is the scalability. This engine isn't locked into a narrow niche of exotic applications. The design is inherently modular. One core cylinder assembly can be replicated, multiplied, or downsized, depending on the platform. Koenigsegg has shown internal diagrams of future possibilities, everything from two-cylinder drone applications to four-cylinder motorcycle builds to six-cylinder aviation configurations. Each module functions independently, controlled by a centralized ECU system that adjusts timing and ignition across cylinders in real time. It's not just efficient, it's intelligent, and it doesn't stop at gasoline. The dark matter engine can run on a spectrum of fuels, synthetic fuels, biofuels, even hydrogen-dominant blends, with only minor adjustments to its control algorithms. In an age where fuel source flexibility may become more important than pure performance, this changes everything. It opens the door to sustainability without the sacrifice of range, recharging infrastructure, or environmental control. While EVs struggle with battery degradation, mining limitations, and grid instability, Koenigsegg's approach quietly bypasses these bottlenecks. They've created a system that doesn't ask you to change the world around it. It adapts to the world you live in. One of the most mind-bending aspects of the engine is the way it deals with sound. Yes, sound, because in the world of hypercars, the emotional signature of an engine is just as important as its stats. The dark matter engine doesn't roar like a traditional V8, but it doesn't whisper like an electric motor either. It has a new voice, sharp, high-pitched, almost digital in its rhythm, like a cross between a jet turbine and a highly tuned rotary engine. It's a sound that tells you something alien is happening under the hood, something outside the bounds of conventional combustion. Koenigsegg didn't want to kill the thrill. They wanted to evolve it. And what they've created is a new form of automotive soul, one that resonates not from vibration, but from precision. Inside the cabin, the experience is no less surreal. The Gemera's driver display doesn't just show RPMs and boost levels. It shows live thermal maps of each combustion chamber, intake pressure modulation down to each valve, and adaptive torque split control that updates hundreds of times per second. The engine is no longer a black box of mystery. It's a transparent, reactive machine that lets you see its decision-making in real time. It's like watching an orchestra conductor guide an ensemble, except instead of violins and cellos, you're watching air, fire, and motion bend to your will. And this brings us to the question that everyone's been asking. Why now? Why bring this out in 2025 when the entire industry is pivoting to electric motors and renewable grids? The answer is both visionary and pragmatic. Koenigsegg knows the electrification revolution is real. They're not fighting it. They're augmenting it. In fact, the Gemera doesn't rely on the dark matter engine alone. It pairs it with electric motors and a torque vectoring AWD system, creating one of the most advanced hybrid powertrains ever envisioned. This isn't about replacing electric, it's about replacing compromise. In Koenigsegg's vision of the future, cars are not bound by a singular ideology. They are tools of engineering perfection, each part selected for its superiority, not for its trendiness. And that's what the dark matter engine represents. A triumph of engineering over hype, a refusal to settle for binary thinking, a living challenge to every CEO who said combustion was dead. The implications extend beyond the automotive world. Aerospace companies have already reached out to Koenigsegg's engineering team, inquiring about scaled versions of the engine for vertical takeoff drones and high-altitude atmospheric platforms. Defense contractors are rumored to be testing prototype modules for use in lightweight, high-speed reconnaissance vehicles. Even Formula One teams, under strict emissions and efficiency regulations, are quietly studying the design for future power unit integration. This isn't just a Koenigsegg story anymore. This is an inflection point for mechanical engineering across multiple industries. What makes this so ironic is that it came from a company with just a few hundred employees, nestled in a small facility in Ängelholm, Sweden. While the rest of the world was pouring billions into battery R&D, Koenigsegg was sketching out equations on napkins and testing ignition methods with former fighter jet engineers. They didn't just beat the competition, they ignored it. And in doing so, they built something the world wasn't prepared for. The dark matter engine may be the greatest mechanical paradox of our time, an ultra-efficient, ultra-powerful combustion engine that thrives in an era built to kill combustion. But Koenigsegg didn't just give it life. They gave it purpose. And now it's up to the rest of the world to catch up. At first, the world didn't quite believe it. Many dismissed the announcement as clever branding, just another performance engine with a flashy name. Dark matter, after all, sounded more like science fiction than mechanical reality. But then came the lab tests, the bench dyno results, the thermal imaging, the real-world telemetry from the pre-production Gemera. Independent engineers, once skeptical, started reviewing the data and coming to the same jaw-dropping conclusion. This engine was rewriting the laws of internal combustion, piece by precision machine piece. Major automotive institutions scrambled to understand how Koenigsegg had accomplished something no one else had. Underneath the headlines, behind closed doors, rival automakers quietly launched task forces to analyze every public patent Koenigsegg had filed over the last decade. Engineers pored over the technical language, trying to reverse engineer the combustion profiles and electronic architecture. They couldn't believe what they found, a framework that had been hiding in plain sight for years. Koenigsegg hadn't just dropped a surprise in 2025. They had been telegraphing their intentions all along. The dark matter engine wasn't a sudden leap. It was a long con of genius. And now that it's real, the shockwaves are cascading outward. Nations with fragile energy grids, those unable to support massive EV infrastructure, are reevaluating their electrification timelines. Smaller car manufacturers, previously terrified of the cost barriers to competing in an EV-dominated world, now see a second chance through modular combustion innovation. Even global shipping conglomerates and rail networks, long reliant on diesel, are initiating exploratory talks with Koenigsegg's partners to develop scaled-up versions of the dark matter system for freight locomotion. The narrative of energy has split, and Koenigsegg is writing the chapter that was missing. At the center of it all is Christian von Koenigsegg himself. He stands not just as the face of the company, but as the embodiment of a philosophy that limitations are illusions created by those unwilling to explore deeper truths. Where others saw the death of combustion, he saw its rebirth. Where others chased silicon, he doubled down on metallurgy, pressure dynamics, and intelligent fuel behavior. He understood something that most corporations had forgotten in their rush to adapt. Engineering doesn't evolve through consensus. It evolves through courage. Christian's team wasn't bound by quarterly earnings or the fear of market backlash. Koenigsegg remained independent, nimble, and relentlessly curious. They weren't trying to change public opinion. They were focused entirely on changing what was technically possible. And in doing so, they didn't just save combustion. They purified it. They burned away its inefficiencies, its waste, its noise, and left behind something almost alien in its precision. A power plant that behaved more like an AI-driven instrument than an engine. Now there's something else unfolding, something Koenigsegg has been hinting at in cryptic interviews and limited access engineering summits. It's a concept they're calling closed-loop energy modulation. Essentially, it's the next phase of the dark matter engine's evolution. Right now, the engine generates power with near-perfect thermal efficiency, yes, but soon it may also become a self-regulating energy system. Through adaptive feedback loops, it will dynamically adjust not just torque and RPM, but how combustion occurs based on real-time environmental conditions, vehicle load, fuel type, and even driver behavior. In other words, a thinking engine. This system could decide on the fly how best to distribute its energy, whether to assist the battery pack, regenerate kinetic energy during braking, or focus all output on propulsion. It's not about making one part of the vehicle smarter. It's about making the entire power ecosystem inside the car operate as a unified organism. And once that framework is perfected, it can spread into trucks, ships, planes, even off-grid power generators. Anywhere there's a need for power without compromise. What's remarkable is how Koenigsegg kept this secret for so long. While other companies hosted flashy concept car unveilings and made billion-dollar press releases about battery supply chains, Koenigsegg worked quietly, meticulously. Their facilities didn't leak. Their testing protocols were discreet. Every employee understood the magnitude of what they were building, and they guarded it with religious fervor. The payoff wasn't just in technological superiority, it was in timing. When the rest of the world was beginning to show signs of fatigue from battery dependence, concerns over cobalt mining, lithium supply, power grid instability, Koenigsegg opened the curtain. And what they revealed was a masterpiece. And now the world faces a crossroads. For decades, the debate around the future of transportation has been defined by two poles: combustion versus electric. But what Koenigsegg has introduced is something entirely different. Not a middle ground, but a third path. A path defined not by compromise, but by transcendence. One where power is no longer limited by legacy systems or fashionable ideologies, but by the full spectrum of scientific possibility. What does this mean for the everyday driver? Maybe not much right away. The dark matter engine is, after all, launching in a hypercar priced well beyond the reach of most. But that's how every revolution begins, at the edge, in the experimental, in the places where risk and brilliance collide. Over time, the technologies pioneered in that engine will find their way into more affordable applications. The software algorithms, the ignition systems, the modular architecture, these can be licensed, scaled, and integrated into vehicles far beyond the Chimera's lineage. In 5 years, you might see dark matter-derived engines in high-performance motorcycles, luxury SUVs, or even emergency response vehicles that require instant torque and long operating times without grid reliance. In 10 years, you might see them replacing entire diesel fleets in countries without electric infrastructure. And in 20 years, you might look back on 2025 not as the year the EV revolution matured, but as the year we remembered what combustion could become. Koenigsegg didn't set out to destroy electric cars. They set out to rescue mechanical engineering from stagnation. And in doing so, they created not just an engine, but a beacon, a signal to every garage tinkerer, every disillusioned inventor, and every dreamer who believed the age of impossible machines was over. The future isn't battery or bust. The future is brilliance, wherever it may emerge. And if brilliance sometimes sounds like dark matter igniting in a polished cylinder at 10,000 RPM, so be it.